welcome back to the channel. In today's video, we are going to discuss one of the most crucial concepts in the machine learning, the learning curve. If you have ever trained a machine learning model, you have probably heard the term learning curve thrown out. But what does it actually means? And more importantly, how can we use it to improve our models? Well, stick around because we are going to break it down with some simple code using Python. By the end of the video, you will have a solid understanding of what a learning curve is and how it can help you make smarter decisions during model training. At its core, a learning curve shows how your model performance improve as it's exposed to the new more data or training time. It is typically a plot that compares the training and validation error as the model is trained over time. So why this is important? Well, by analyzing the learning curve, we can get insight into whether our model is underfitting, overfitting, or just right. This helps us figure out if we need more data, more feature, or if the model architecture need tweaking. Here are a few types of learning curve you might encounter. Let's break them down. Underfitting. This means whether both the training and validation are high, meaning the model isn't learning well even on the training data. Overfitting. This is when the training error is very low, but the validation error is high, indicating the model is memorizing the training data instead of generalizing well to the new data. Just right, this is the ideal case where both training and validation errors decrease over time and eventually stabilize. All right, now we have the understanding. We understand the theory. Let's jump into some code. We'll use simple data set to plot learning curve and analyze it step by step. So we'll start by importing some libraries. So here we use matplotlib for plotting, scikit-learn for our model and data set. So let me import those. First, we load the sample data, the famous iris dataset, and split it to training and testing sets. Let me run this cell. Next, we will set up a support vector classifier model, and we are going to use this model together to generate the learning curve. So to create the model, let me just run this cell. Now, here's the fun part. Let's plot the learning curve. We'll use the learning curve from scikit-learn and which automatically split our training data into a smaller training set, train the model on them, and record the accuracy on both the training and validation set. So here I'm generating it generates the learning curve data, and the next portion calculate the mean and the standard deviation for the train and validation score. So now let's visualize the learning curve. We'll plot the training and validation score against the number of the training sample. This code will give us the plot showing how the model's accuracy changes as we train it on the different amount of data, and we can clearly see how the training and validation error evolves. So let's illustrate what we see here. If the plot shows that the training and validation error are high and do not improve with more data, it likely means our model is underfitting. So if training score is very high, the but the validation score is much lower, then probably it is the condition of overfitting. This indicates that the model is memorizing the training data instead of learning the underlying pattern. Hence, the sweet spot when both the training and validation score improves and stabilize at the same value. So this suggests the model is generalizing well to new and unseen data. So what did we learn? The learning curve is a powerful tool for diagnosing problem with your model, like underfitting and overfitting. By using the learning curve, we can decide if we need more data and more complex model, or perhaps different hyperparameter. Here's a quick recap. If you have a high training error and the validation error, then it is underfitting. High training error is lower, but validation error is high, it is overfitting. And if both the error decreases and stabilize, that's a good fit. So before we wrap up, here's a quick few tips. Use more cross validation split to get more accurate learning curve. Remember that the learning curve are not just for classification problem, they apply to regression tasks too. And that's for the today video. I hope it gives a clear understanding to how to interpret learning curves in the machine learning. Thank you.